Students, welcome back. Coming to the next, that is a code division multiple access in mobile computing. In the previous video, I explained about the GPRS technology. Now let's see the code division multiple access, CDMA. So what's the use of this CDMA? Let's see. A CDMA is a spread spectrum technology. We call it as a spread spectrum technology. Why we calling this as a spread spectrum technology? Because it is allowing many users to occupy the same time and frequency allocation in a given band or a space. So that's why we calling it as a spread. It is spreading. So let me write it. Allowing CDMA, allowing many users to occupy the same time and frequency allocation is given. The same time and the frequency allocation is in a given band. In a given band or a space. So in a given band or in a given space, it is going to allocate, occupy the same time and the frequency. The spectral spreading of transmitted signal gives to CDMA its multiple access capability. So it is a form of direct sequence. It is a form of direct sequence spread spectrum communication. So we call it as a CDMA is a direct sequence spread spectrum communication. Now let's see what are the benefits of using this code division multiple access. Let's see the benefits. So the benefits here are, it is an outstanding voice calls, voice and call quality will be more. Greatest coverage for lower cost. Greatest coverage will be there for lower cost. And packet data, longer talk time. Packet data, longer talk time. And long battery life. And smaller phones. Still some more benefits are fewer dropped calls. So only the less dropped calls will be there. And improved security and privacy. Greater capacity. It's having the greater capacity. Reduced background noise, and interface, and rapid development. So these are all the benefits of the CDMA, the code division multiple access. So with the help of, if you use a CDMA, you will get the voice and the call quality is more, and it covers the large coverage area for the lowest rate, and here the battery life is long, and it only fewer calls will be dropped. It improves the security as well as the privacy. It's having the greater capacity and reduce the background noises, and it also used for the provides the feature for rapid development. So these are the benefits of the code division multiple access. Let me show you the architecture. So actually the GSM, GPRS, all these architectures will be look samely. Only the difference here is they are using some more features, like some of the extra supporting nodes will be used. So let's take the mobile station. This is a mobile station. The mobile stations are connected to the base stations. Okay. So these base stations are monitored by the base station controller. Okay. So here in the base station controller, they are providing one switch. So this is an extra feature here in the CDMA. A switching network will be connected. So this switching will be sent to the PSTN, that is a public wired phone network, and there to your landline phones. It's a wired phone, wireline telephone. And it also connected to this switch can also connected to this. It's a wireless intelligent add-on functions and database. Okay, and also it connects to other cellular switches also. So here in this GDMA, you don't have the that gateway nodes, gateway supporting nodes and the servicing nodes, whereas in the GPRS. But in the CDMA technology, you are having the switching technology, because this is a spread spectrum. We call it as a spread spectrum. The spectral spreading of transmitting of a signals given to CDMA, it's multiple access capability. It is because of this switching technology, it is distributing to all, means allowing many users to occupy the same time and frequency allocation in a given space. So it is a form of direct sequence spread spectrum communication. So CDMA is different than those traditional ways, and it does not allocate frequency or time in user slots. Okay, the thing you have to remember that it does not allocate frequency or time in user slots, but it allocates both to all users simultaneously at right slots. So whenever they are needed, it will provided the frequency and the bandwidth. Okay, so whenever they required, it provides the time and the frequency to that particular slot. So this is the features of this CDMA. I hope you understand. Thank you.
All of us get excited when we see the symbol. But how does it work? Ever wondered how millions of subscribers are served by telecom operators simultaneously? Hi everyone. Welcome to the world of long-term evolution. Today we will show how multiple users access network using multiplexing.
In the last video we have shown how two signals were combined over a common pathway in duplexing. So, what exactly is multiplexing? Multiplexing is the process of combining multiple signals and transmitting them over a common channel. Then what is multiple access? When multiplexing is used to allow multiple users to communicate over a single common channel, we call it multiple access. In other words, multiple access is nothing but the application of multiplexing. So here's a Wi-Fi hotspot sharing its internet connection among multiple users by providing them a frequency block over which they can transmit and receive data. The greater the size of this block, greater is the throughput. Telecommunication systems, which mostly use radio waves as a communication link with end users, have employed several ways to share this resource.
CDMA, which uses frequency division multiplexing, provides chunks of the frequency spectrum to each user for data transmission. Generally, the data is generated at baseband and modulated at varying radio frequencies. Guard bands are introduced to avoid any interference. AMPS or the first generation analog systems used FDMA to provide each user a duplex channel with one-way bandwidth of 30 kHz. TDMA, which uses time division multiplexing, allows multiple users to share a common frequency band by allocating different time slots. Thus, in an N-channel TDMA, where each channel is given a time slot of 2 seconds, signals coming from each user will be transmitted at intervals of N into T seconds. This technology was used in the 2G systems like GSM, GPRS and EDGE. Each user was provided one of 8 TDMA slots and a bandwidth of 200 kHz. Dynamic resource allocation meant more users could be supported, but each channel could support only 8 active users at a time. CDMA based on code division multiplexing is a technique in which the data bits are modulated by a high-frequency orthogonal sequence of bits such as Walsh codes or pseudo-random codes such as gold codes to spread the signals over a large frequency band. Multiple such signals from different users are then transmitted over the same frequency band. In order to retrieve the signal, receiver must have the same spreading sequence, which is multiplied to this composite signal in a process called dispreading. This makes CDMA very secure and robust. It was used in 3GPP2 standards such as CDMA and CDMA Evolution Data Optimized standards. Wideband CDMA or WCDMA spreads the signals over an even higher bandwidth. This was used in the 3G standards of 3GPP from UMTS to HSPA+, where the available bandwidth was 5 MHz compared to 1.25 MHz used in CDMA. There are other multiple access techniques like wavelength division multiple access, which is used in fiber optics, and space division multiple access, which refers to spectrum reuse over non-overlapping areas.
As the number of users and their demand started growing, communication networks evolved from 1G to 4G. Radio PARD was significantly enhanced from GSM to HSPA+. Now, focus was shifted towards better spectral efficiency by using higher modulation order like QPSK, 8PSK, 16COM, 64COM, etc. WCDMA improved upon some of the problems of earlier generations like, first, low data rates. In GSM, effective bandwidth for a user was only 25 kHz. Second, congestion at peak hours, as the frequency chunks and time slots were very limited. Third, resource wastage. Resources remained idle when users were inactive. Fourth, poor spectral efficiency, due to guard bands and guard periods used for avoid interference. But, exhaustion of spectrum, need for even higher data rates, and spectral efficiency lead us towards OFDMA. OFDMA comes with several advantages over WCDMA like bandwidth scalability, carrier aggregation, low intersymbol interference. OFDMA uses orthogonal subcarriers equally spaced at 15 kHz. Users are provided a subset of these subcarriers for data transmission. Unlike FDMA or TDMA, OFDMA allows the users to access variable bandwidth depending upon the resource availability. Also, since these subcarriers are orthogonal, there are no guard bands between them. It was first introduced in Wi-Fi, and subsequently in WiMAX, by IEEE, but as WiMAX lacked backward compatibility and support for mobile wireless at its inception, operators remained stuck with WCDMA. This changed with the introduction of LTE, which brought OFDMA to the forefront of today's mobile networks.
So, today we showed what were the different multiple access techniques that were used in various generations of wireless communication. In our next video, we will dive deep into OFDMA and SCFDMA, the two pillars of 4G. Hope you enjoyed the video.